Good afternoon. I'm Bill Sloan from Kentucky, and I'm NASFA's current president. I'll be the moderator for the webinar. Thank you for participating in this joint webinar offered by NASFA and AAPCA. Today's webinar is titled U.S. EPA and State Perspectives on Clean Air Act Rules for Stationary and Emergency Engines. First, let me introduce the associations. NASFA is the National Association of State Facilities Administrators and is an association dedicated exclusively to the state facilities professional and the unique challenges they face. Our members are responsible for the planning, development, operations, and maintenance of state facilities and infrastructure. For more information about NASFA, visit www.nasfa.net, that's NASFA. The Association of Air Pollution Control Agencies, also known as AAPCA, is a consensus-driven organization focused on assisting state and local air quality agencies and personnel with implementation and technical issues associated with the Federal Clean Air Act. AAPCA's members work collaboratively on behalf of states and the communities they protect to act as a conduit for and provide feedback to federal regulators on air quality rules that have significant impacts across the entire nation. 18 state environmental agencies currently sit on AAPCA's board. They are housed in Lexington, Kentucky, as an affiliated association of the Council of State Governments. More information about AAPCA may be found by visiting www.cleanairact, that's one word, .org. Now here are a few logistics about the webinar. First, we will answer questions at the end of the presentations. However, feel free to submit your questions during the presentation. To ask a question, please type the question into the questions box on your dashboard and press the send button. The webinar is being recorded and will be posted on NASFA's website, that's nasfa.net, under the Learning Series tab. So let's get started. I'm pleased to introduce Melanie King, an environmental engineer in the Energy Strategies Group at the U.S. Environmental Protection Agency in Research Triangle Park, North Carolina. Melanie is currently working on developing and implementing regulations for emissions from stationary internal combustion engines and combustion turbines. Prior to joining EPA, she worked for the North Carolina Division of Air Quality. And with that, I'll turn it over to Melanie.
Great, and thanks everyone for being on the webinar today. So I'm going to cover EPA's air quality regulations for stationary engines. And I thought I'd start out by addressing one of the questions that I most commonly get asked, which is what is a stationary engine? And basically we define it by what it's not. We say it doesn't include any engines that are used in motor vehicles, and then any engines that are used in what we call mobile non-road equipment. And the three types of mobile non-road engines are anything that's self-propelled, like a tractor, anything that's propelled while performing its function, like a lawnmower, and then anything that's portable or transportable. For example, if you had a generator that is on a trailer, that would be an example of a portable or transportable engine. But one thing I wanted to note is that for that third category of mobile non-road engines, that portable or transportable category, if you have anything that fits in that category that remains in the same location for more than 12 months or for the full annual operating period of a seasonal source, then it's considered to be a stationary engine. And it's considered to be stationary from the day one that it started remaining in that location, not from, not after it's there for a year. And the way that we define location is any single site at a facility, structure, building, or installation. So if you have engines that are in motor vehicles and engines that are mobile non-road equipment, then they're not subject to these rules. If you have stationary engines that are remaining in one location, then they would be subject. some key terms that I'll use throughout the presentation that I wanted to kind of kick off with. These rules are known as the RICE rules. You'll hear that said a lot, and RICE stands for Reciprocating Internal Combustion Engines. There's two types of regulations that apply. There's what we call our NESHAP, National Emission Standards for Hazardous Air Pollutants. That covers, that regulates what we call HAP, Hazardous Air Pollutants. And those are pollutants such as, for example, from engines, you have like formaldehyde, benzene, toluene, basically air toxics. Those regulations apply to what we call major sources of hazardous air pollutants, and those are those that emit 10 tons or more per year of a single HAP or 25 tons or more per year of combined HAP. And then they apply to what we call area sources of hazardous air pollutant, and that's basically any source that's not a major source. So if you have, you know, a source category that emits hazardous air pollutants, then you're either going to be a major source or an area source. So that's some key terms that are used for our NESHAP regulation. And then the second type of regulation that we have is what we call our New Source Performance Standards, or NSPS. And that addresses emissions of criteria pollutants, which are things such as carbon monoxide, particulate matter, nitrogen oxides, volatile organic compounds. And then for within stationary engines, we have two different types of engines. We have compression ignition, which is basically your diesel engines, and any dual fuel engines that use diesel more than 2% of the time. And then you have your spark ignition engines, which, so that's your natural gas, gasoline, propane, landfill and digester gas. Within spark ignition engines, you have different types. You have rich burn and lean burn, and then you have two-stroke and four-stroke. So you'll see those terms used. We don't generally break it down like that for compression ignition engines because they're all generally four-stroke lean burn engines. So we don't generally subcategorize compression ignition further by the burn and the stroke. So we have three regulations that apply to stationary engines. We have our NESHAP, which applies to what we call both existing, which is older engines, and then new engines. And the NESHAP applies, there's just one regulation that applies to both compression ignition and spark ignition engines. And I've put there the citation where you can find the regulations in the Code of Federal Regulations. That's what CFR stands for. And then we have one New Source Performance Standard, or NSPS, for compression ignition engines, and then one for spark ignition engines. The NSPS for compression ignition engines applies to those that are ordered after July 11th, 05 and manufactured after April 1st of 06, and then older engines that are modified or reconstructed after July 11th, 05. So the NSPS only applies to engines that were constructed after a certain date, and then any older engines that are modified or reconstructed, and we'll talk later on about what those terms mean. And then, so that's compression ignition. Spark ignition applies to stationary spark ignition engines that were ordered after, and you can see the specific date depends on the type of engine. It's, you know, 2007 to 2009 timeframe. And then older engines that are modified or reconstructed after June 12th of 2006. So just keep in mind that NESHAP applies to both older existing engines and then new engines, and then the NSPS generally applies to, you know, newer engines manufactured after specific dates, and then any older engines that are modified or reconstructed. And just to give you an idea of how we generally subcategorize engines within these rulemakings, we break it down compression and spark ignition. And then we have subcategories for non-emergency engines, emergency engines, landfill digester gas, and then by the burn type and the stroke, which we talked about earlier. I'm going to cover what is an emergency engine, and then non-emergency engines would be basically anything that doesn't fall into the emergency engine definition, and then also there's a landfill and digester gas engines. So to give you an idea of what we categorize as an emergency engine, I'll put an excerpt here of the definition in the rulemaking, you know, operated to provide power or work during an emergency situation. We give some examples in the regulations of types of emergency engines. They're by no means exhaustive, so there certainly can be other types of emergency engines than what we use as examples in the regulation. So, and then an emergency, in order to be considered an emergency engine, the engine can operate in what we call non-emergency situations only as specified in the regulations. And to further illustrate that, these are the limitations that are placed on operation of emergency engines. So there's no limit on the use in an emergency situation. So if there's a hurricane or an ice storm, fire or flood, something like that, and you need to run your engine, there's no limit on the number of hours you can run it in those kinds of situations. There's a limit of 100 hours per calendar year for maintenance and testing of the engine itself. And then within that, you can use up to 50 of that 100 hours per year for two types of situations. A non-emergency situation, as long as there's no financial arrangement for running the engine. So an example of that would be, one example I've heard is if there's a thunderstorm in the area, for example, and you have a hospital, and you might want to turn on your generators so that if the power does go out, you don't have any kind of blips in the power. That's the type of thing that you can run it for this 50 hours, where there's a non-emergency situation with no financial arrangement. The second is we specify that you can use the engine in a financial arrangement with another entity, typically your utility, in order to maintain local reliability, but there's several criteria that have to be met, which I've listed there. I won't read them all through, but if those criteria are met, then the engine can be run for those 50 hours. One thing I wanted to make it clear, though, is if you have a backup generator at your facility, for example, and you want to run it for, not just emergency situations, but you want to use it for peak shaving, for example, which is not one of the uses specified here, you can do that with your generator. It would just mean that your generator doesn't meet our definition of an emergency engine, and it needs to meet the criteria or the requirements in our regulations that apply to what we call a non-emergency engine. So if you don't want to be limited by these limitations on hours of operation, then that's okay, as long as your engine meets the standards that apply to a non-emergency engine. One thing I want to mention, because this is kind of a recent change to the rule, there used to be additional types of situations that the rule allowed emergency engines to be operated for. They were for emergency demand response and voltage and frequency deviations. There was a court decision last year that vacated those provisions, and that vacature took effect earlier this month. So the impact of that is that any engines that are operating for emergency demand response and voltage frequency deviations, which were the vacated provisions, have to comply with the emission standards and the regulations for non-emergency engines. And we have some guidance on our website, which I have a link to there, that talks about this in a little bit more detail. And then separately, we had asked for and received a voluntary remand from the court of the provision that allowed emergency engines to operate for up to 50 hours per year in a financial arrangement to maintain local reliability. So what that means is that we're kind of taking a second look at that provision, and we may at some point in the future propose some changes, or maybe try to further bolster the regulatory record for that provision. But right now it remains in the rule, and engines can still operate for that purpose. It has not been vacated. So I'm next going to go into a little bit more detail about the NESHAP, and then I'll cover the two separate NSPS regulations. To start out with some background on the NESHAP, as I said, the purpose of the NESHAP is to regulate emissions of hazardous air pollutants. Our regulation for engines covers engines at both major and area sources of hazardous air pollutants. Some of our NESHAP regulations for other types of sources, for example, turbines, only regulates major sources, but our NESHAP for engines regulates both major and area sources. It covers all sizes of engines. There's no size cutoff below which an engine's not subject to the rule. The only types of stationary engines that are not subject to the regulation are existing emergency engines located at residential, institutional, and commercial area sources, and that aren't used for that 50 hours to supply power in a financial arrangement for local reliability. We have a memo on our website that I put a link to there that gives some more guidance about what we consider to be a residential, institutional, or commercial facility. So the requirements in the regulation are different depending on whether your engine is considered a quote-unquote existing engine or a new engine. If your engine is greater than 500 horsepower and it's at a major source of hazardous air pollutants, it's existing if construction commenced before December 19th of 2002. If it's less than or equal to 500 horsepower and at a major source of hazardous air pollutants, or if it's any size at an area source of hazardous air pollutants, then it's considered to be existing if construction commenced before June 12th of 2006. And the way that we define construction is it's when the owner or operator of the engine entered into a contractual obligation for the on-site installation of the engine. And it doesn't include moving an engine to a new location. So if you had an engine that was originally installed in 1980, for example, and then in 2012 you picked up that engine and you moved it to a new location, or you sold it and someone else took ownership and they moved it to a new location, the construction date would remain that original 1980 installation date. It wouldn't get a new construction date of 2012. So I'm going to get into more specifics about the requirements for engines and the regulation. I'm going to first talk about emergency engines at area sources, which is, I suspect, what a lot of the folks on this call, the engines that they deal with, might fall into this category. So if you have an existing emergency engine at an area source of hazardous air pollutant, I've listed here what the compliance requirements are. We have maintenance requirements, which are change the oil, filter, and inspect hoses and belts, air cleaner, and spark plugs on a specified schedule. We do say that you can, instead of changing the oil every 500 hours, you can use an oil analysis program where you analyze the oil for compounds that we set out, or parameters that we set out in the rules, such as total base number, total acid number, viscosity, and % water content. And if the oil hasn't reached the condemning limits that we set out in the rule, then you can, you don't have to change it. You can go another interval, another 500 hours, and then either change it or do another oil analysis. We specify that you have to operate and maintain it per the manufacturer's instructions or your own maintenance plan. If the engine is above 100 horsepower and has a displacement of less than 30 liters per cylinder, and it's operating for that 50 hours in a financial arrangement to maintain local reliability, then it has to use ultra-low sulfur diesel. You have to have a non-resettable hour meter, and you have to keep records of the hours of operation and maintenance. We do not require that you submit any initial notifications for that type of engine. That's for existing engines. If you have a new engine, then what the NESHAP regulation requires is that that new engine meet their NSPS regulation. So if it's compression ignition, that's a subpart quadruple I. If it's spark ignition, that's a subpart quadruple J. So it just has to meet the new source performance standards, and it has no other requirements under the NESHAP. We do have a reporting requirement for certain emergency engines, those that are greater than 100 horsepower and are operated for up to that 50 hours per year in a financial arrangement for local reliability. This is a new requirement that we just started doing this year. So the first reports that we got were the first part of this year. So facilities need to report the name and the address, some information about the engine, some information about any operation that they did for that 50 hours for local reliability, and then any deviations from the fuel requirement. And that report is submitted electronically through our electronic reporting interface. And then they have to do that report annually, beginning this year, like I said, and then every year going forward. So that was their requirements for existing emergency engines at area sources. Next, I'm going to cover non-emergency engines at area sources. So for these engines, you can see that the requirements differ depending on what category of engine you fall in. So with this regulation, it's very important if you're trying to determine what applies to your engine that you have, complete information about your engine. What type, is it compression or spark ignition? What's the horsepower? If it's spark ignition, if it's 2-stroke, 4-stroke, etc. So you can see that for the most part, engines have maintenance requirements that are similar to what we talked about for emergency engines. These cells that I highlighted here in yellow, those are the engines that actually have to meet a numeric emission limit for carbon monoxide. So that would be your non-emergency compression ignition engines above 300 horsepower, and then your non-emergency 4-stroke spark ignition engines that are not in remote areas. And the way that we define remote, it's set out in the rule, but it's generally based on your proximity to buildings intended for human occupancy. So those cells highlighted in yellow, those are the engines that we expect would need to be retrofit with an emission control device, such as an oxidation catalyst, in order to meet the applicable emission standards in the rule. So that's the table there is for existing engines, and then below for new non-emergency engines, similar to what we talked about for emergency engines, they just have to meet whatever requirements apply to them in our new source performance standards, and they have no further requirements under the NESHAP. So I'm not going to go over all of these tables in great detail, more providing it for information that you can look at after the webinar. But this kind of just shows you that your compliance requirements for these engines depend heavily on what type of engine you have. If you have one of those that's subject to a numeric emission standard, then you're going to have to do have stack testing conducted on the engine. You're going to have some operating limitations that you have to meet. You're going to have to submit notifications, compliance reporting, ultra-low sulfur diesel if it's a diesel engine. So, it's a lot more involved if you have an engine that's subject to a numeric emission limit for carbon monoxide. For those engines that are just subject to the maintenance requirements, they have similar compliance requirements as those that we discussed for emergency engines. Maintain per the manufacturer's instructions, keep records. They do not have to submit any notifications. So those were the requirements for engines at area sources, and next I'm going to go over the requirements for engines at major sources of hazardous air pollutants. And again, here you can see that the specific requirement depends heavily on the type of engine that you have. But for these, you can see they have more numeric emission standards for carbon monoxide, or in the case of the 4-stroke rich burn engines, they have a formaldehyde limit. That's what the CH2O is. The cells that I highlighted in yellow, again, those are the engines that we expect would have to retrofit with an emission control device, such as a catalyst, in order to be able to meet those emission standards. So the slide before is existing engines. This slide is new engines, and again, you can see the specific requirement depends on the type of engine, but there are, a good number that have numeric emission limits. For the smaller engines, generally those less than 500 horsepower or less than 250 for the 4-stroke mean burn engines, their requirement is only to comply with the new source performance standards, and they have no other requirements under the NESHAP. So again, these are the compliance requirements. I won't go over them in great detail, but they're similar to what I showed a few slides ago. If you have a numeric emission limit, you've got stack testing, reporting, perhaps a fuel requirement. For some categories of engines, we have only a notification or reporting requirement. So again, you really need to have nailed down what type of engine you have before you can try to determine what applies to that engine. For some, the ones that are just subject to the maintenance requirements, the change oil, et cetera, again, they have just operation and maintenance, record keeping, and then reporting for certain emergency engines. So that gives you an overview of our NESHAP regulation. Next, I'm going to cover our new source performance standard. And so I'm going to first start with our compression ignition engine. Again, that's our basically diesel engine new source performance standard. So this regulation applies to compression ignition engines that constructed after July 11th, 2005 and manufactured after April 106 or July 106 if it's a fire pump engine. And one thing I wanted to mention and highlight here is that we define constructed in the NSPS differently than the way we define it in the NESHAP. In the NESHAP, as I said, it was the entered into a contractual obligation for the on-site installation of the engine. For the NSPS, we define constructed as when the engine was ordered, so it's not necessarily tied to the on-site installation of the engine. So it applies to engines constructed and manufactured after those dates. And then it also applies to any engine that's modified or reconstructed after July 11th, 05. So if you have a 1980 engine that you modify or reconstruct after July 11th of 05, then it becomes subject to the NSPS. Modification is you make a change that results in an increase in emissions of a regulated pollutant. And reconstructed is when you replace the components of an existing engine such that the cost of the new components exceeds 50% of the cost of a comparable entirely new engine, and it's feasible to meet the applicable standards. So the NSPS regulation is a little bit different than the NESHAP because it also applies to manufacturers of stationary compression ignition engine. The NESHAP only applies to owners and operators, and NSPS applies to manufacturers as well as owners and operators. So what it requires for the manufacturers is that they certify 2007 model year and later engines that have a displacement of less than 30 liters per cylinder. And by certify, I mean they get an EPA certificate of conformity for the engine. That's an example there of what a certificate of conformity looks like. And they are required to label the engine that, and it should say that this engine conforms to EPA standards, and, there are some other engines that, some other information that they have to put on the label. So it should, if the engine is certified, then the manufacturer should label it as such, and they should be able to provide documentation that is certified. Every certified engine is part of an engine family, so they should be able to provide you with an engine family number. So that's for the manufacturers. If you're an owner or an operator of the engine, your compliance requirements are for 2007 model year and later, or if it's a fire pump engine, the model year is a little bit different. But you're required to purchase a certified engine. And so that engine would be certified to the applicable emission standards in the rule. And they're for nitrogen oxides, carbon monoxide, particulate matter, and hydrocarbons. And they're generally equivalent to what we call the tier standards, which were first adopted for non-road engines. So if you hear the terminology tier 2, tier 3, tier 4 engines, that's what they're talking about. Those are the emission standards that apply to the engine. So you have to purchase a certified engine. You have to install, configure, operate, and maintain the engine per the manufacturer's instructions. If you do that, then no performance testing is required for that engine. If you do decide to operate that engine differently than the manufacturer's instructions, then you will, as the owner-operator, be required to do performance testing to show that the engine still meets the emission standards. And one example of something that could be done where you might trigger this is if you had an engine that was certified by the manufacturer and it was only certified for ultra-low sulfur diesel fuel. If you decided to convert that engine to a biofuel engine, for example, that could also run on natural gas, then that engine is no longer in the certified configuration, and you would have to do stack testing to show that the engine meets the applicable emission standards. And then the last requirement for these engines that I've listed there is that they use ultra-low sulfur diesel fuel. So that's the owner-operator compliance requirements. There are monitoring, record-keeping, and reporting requirements for some engines. If you have an emergency engine, you have to have a non-resettable hour meter and keep records of operation. You have to do the annual reporting that we talked about earlier in the NESHAP regulation if you're using that engine for in a financial arrangement for up to 50 hours for local reliability. If your engine is equipped with a diesel particulate filter, then you have to have a back pressure monitor and keep records of any corrective actions. And if you have a non-emergency engine above 3,000 horsepower or with a displacement of more than 10 liters per cylinder, there's some notification and record-keeping requirements that would apply to that engine. So that gives you just a quick overview of our new source performance standards for compression ignition engines. I'm going to move now to the NSPS for spark ignition engines. And again, this would be anything natural gas, gasoline, landfill gas, digester gas, propane. So this engine applies to spark ignition engines that are constructed after June 12th of 2006 and manufactured on or after, and then the specific date ranges from July 107 to January 09, depends on the type of engine that you have. And again, here constructed is defined as ordered. So it applies to spark ignition engines constructed after those dates, and then any older engine that's modified or reconstructed after June 12th of 2006, and modification and reconstructed have the same definitions that I talked about earlier with the compression ignition engine rule. So this rule is a little bit different than the compression ignition engine rule in that not every type of engine has to be certified by the manufacturer. With this rule, the only engines that manufacturers are required to certify are those that are less than 25 horsepower or those that are greater than 25 horsepower and that are in gasoline or rich burn LPG engines. So anything that's greater than 25 horsepower and natural gas fired, for example, engine manufacturers are not required to certify those engines. I believe that they are voluntarily certifying some engines, but I think the majority of them that are greater than 25 horsepower and that aren't gasoline or rich burn LPG are not being certified. And if you ever need to go and see what engines are certified, we do have that information up on our website. There's a list, a spreadsheet that's posted every year of all the engine families that have been certified. So just in general, the applicable emission standards depend on the type of engine that you have, but they're generally hydrocarbon, carbon monoxide, and nitrogen oxide standards. And for some categories, we have a volatile organic compound or VOC standard rather than the hydrocarbon. But here again, you have to know what type of engine you have in order to be able to figure out which emission standard applies to that engine. And the only fuel requirement that we have in this rule is for gasoline engines. We say that gasoline, you must use gasoline that meets a sulfur limit of 80 parts per million. So those are the emission standards. The compliance requirements, if you have a certified engine, similarly to what we talked about with the compression ignition engines, you just need to install, configure, operate, maintain per the manufacturer's instructions. If you decide not to do that, then you can, but what that means is if you have an engine above 100 horsepower, you're going to have to do performance testing for that engine, and if it's above 500 horsepower, you're going to have to do not only an initial test, but then subsequent testing. If you have an engine that was not originally certified by the manufacturer, you have to have a maintenance plan, and then you have to do performance testing if the engine is above 25 horsepower. There are monitoring, record keeping, and reporting requirements. If it's an emergency engine, non-resettable hour meter, records of hours operation, you have to do that annual reporting that we talked about earlier. If you have an engine that's used for up to that 50 hours in a financial arrangement for local reliability, keep documentation that it's certified, any records of maintenance. If it's a non-certified engine above 500 horsepower, submit an initial notification, and then if you have to do performance testing, you have to submit the results of that testing. So I know I covered a lot of information. These regulations are very complex, and there's a lot to digest. So we have a website that I think has got a lot of really useful information. It's got a lot of the background materials for the rulemakings. There's a lot of compliance assistance materials. We have what we call a regulation navigation tool, which is like kind of a TurboTax type tool where you can go in and put in the type of engine that you have, and it'll parse out the specific parts of the regulation that apply to that type of engine. We have a compilation of all the letters and applicability determinations that we've done, the Q&A document, things like that. So I would encourage you to go to the website if you have questions and want to get further information. I put a link there to also the Electronic Code of Federal Regulations. And then I also put a link to our regional office contacts for these regulations, and that map there shows you which states belong to which regions. If you have like site-specific questions, I have to do performance testing, and I'm not quite sure, what load I need to have my engine running at, or where do I need to submit this notification or things like that, or I'm not quite sure about the applicability of the regulations to my specific engine, then I would encourage you to talk to either your regional office contact, or if you have a state that has taken delegation of the implementation and enforcement of the rule, talk to your state or your local air pollution control agency. And if you're not sure if your state's taking delegation, then our regional offices can let you know if they have or not. So I would encourage you, if you have sort of site-specific questions, definitely reach out to your regional office or your state or local air pollution control agency. And with that, I thank everyone for their attention, and I'm going to turn it back over to Bill to introduce Gary.
Thank you, Melanie. Our next presenter is Gary Saunders, a Special Projects Engineer with the Division of Air Quality at the North Carolina Department of Environmental Quality. Gary has more than 40 years of experience in air-related issues, including emissions testing, permitting, operation and maintenance of control equipment, and permitting, 18 years with the Division of Air Quality. As the chair of as the chair of DAQ's compliance work group, he was a member in the DAQ team that was set up to implement the regulations contained in 40 CFR 63 subpart 4Z. He is one of Raleigh Central Office's main contacts on issues related to compliance with the engine rules. He has a degree in chemical engineering from NC State University, and prior to joining the DAQ, he worked for several engineering consulting firms managing projects on air-related issues. With that, I'll turn it over to Gary.
And thank you, and good afternoon. So Melanie did a very nice job of giving you a summary of the rules, and I'm going to give you the perspective of a state agency that had to implement these rules. So we won't dive deeply into the rules. We'll just talk about some of the issues that have come up over a period of time. A little background on North Carolina and the way that we approached it. First of all, North Carolina DAQ consists of 7 regional offices and the central office. There's also 3 local programs within the state. North Carolina is one of those states that's set up to automatically accept and adopt the delegation of most of the new source performance standards under 40 CFR 60, the NESHAPs under 40 CFR 61, and the MACT GAC rules under 40 CFR 63. There are a few exceptions, but as EPA has promulgated these rules, we've become the administrator in the definition of the rules. So we're enforcing the rules except for those portions of the rules that EPA retains delegation for. As Melanie pointed out, the RICE rules were promulgated for the 40 CFR 63 in 2004, and at that time it affected engines mostly at major sources of HAP, and then there were also rules for the NSPS under the 4I and 4J rules. And at those particular times, I say prior to 2010, if you looked at how DAQ dealt with the requirements of for these engines that were at that time subject to the rules, it was largely a permitting exercise. It was getting the requirements into Title V permits and some smaller source permits. In North Carolina, the Title V permits are developed and sent out of the central office. So for the engines that were affected under 4Z, 4I, and 4J, those were all major sources of either HAPs or they were Title V sources for the other criteria pollutants. Our regional offices deal with the small and synthetic minor, or as Melanie also pointed out, the area sources, and those permits were issued under by the regional offices, and that primarily dealt with small sources that may have had new engines under the 4I and 4J new source performance standards. One other complicating effect, but nonetheless it's not uncommon, is North Carolina also includes some permit exemption rules that exempt certain engines based on size in terms of horsepower or kilowatt hours generated, or the usage in terms of hours of use or fuel usage. So even though these engines may be subject to the requirements of the rule, the net effect is not every affected engine under the rules are required to have a permit, even though, and this is stated in our rules, even though they're required to comply with all the requirements of the federal rules. And because we're the delegated authority, we're the ones that they have to deal with. And this exemption is still true today, and we're going through some rule changes right now, and there will still be exemptions for certain groups of engines that won't have an operating permit associated with them. But that's the background. After EPA promulgated a major change to the Quad Z rules in 2010, what we realized as a state was all of a sudden we had a very large increase in the number of affected engines under the rule. Now, I'll be honest, we did consider handing the delegation of authority for the rules and specifically the 4Z rules back to EPA because we just knew there were a large number of engines that would be affected, and we weren't really sure how we would deal with this. But our planning group and a group that we have within the planning group and our regional offices that we call the MACT Task Force made an initial assessment of the rule changes, and we developed an implementation team to look at who was affected by these rules in greater detail and to propose what alternatives we might have to the DAQ management. So when we set this up a few years ago, it consisted of a core of people here in the central office and then members of each one of our regional offices. So each regional office contributed at least one person to the discussion of and quantifying of what was going on. And in the central office, again, it was the MACT Task Force. We have a permit work group within DAQ and a compliance work group, which I'm currently the chair of, and that's how I got involved in the fun and games of RICE rules. A rule that I tell people that I never ever intended to learn back about 9 years ago. So my life has changed very dramatically over the last 9 years. This implementation team concept, by the way, is something that we've used for other rules, boiler rules and a few others, because we find that it works well in terms of getting our brains around what it is that we have to do in order to get the federal rules implemented down at the state and local level. So what do we do? Well, the first thing was, how big of an impact were we going to be dealing with? For permitted facilities around the state, we had a basic inventory of all the engines at sources of our permitted facilities. And these are very round numbers, but overall, all the engines we kind of knew about at the time. There were approximately 2,300 engines around the state that would be affected. Some regions within the state are more affected than others because, for example, the eastern part of the state is more likely to be affected by hurricanes. So you'll find a lot more emergency engines down there that might show up in kind of dual purpose operation. Most of these engines are compression ignition engines. That was one of the other things that cropped up. And a fair number of these 2,300 engines are used exclusively as emergency engines. I mean, that's the only time that they're used. They don't peak shave. They're not part of any other sort of program. When the lights go off, those engines go on. We do have a small number of engines around the state that are located at industrial facilities that are peak shavers. So they are not emergency engines, but they do have a financial arrangement that cuts down their costs at certain times during the day. And we also have a small minority of spark-ignited engines burning natural gas here in the state, as well as some other engines, which I'll discuss a little bit further. life got a little bit more interesting from an agency standpoint in trying to deal with the permit exempt facilities. I mean, we had no direct contact with these facilities other than the fact that the rules applied. And these were the challenge that we were really faced with in terms of outreach and how we would deal with these engines. And before we get to those, we'll talk about those permitted facilities. One of the things that we have here within the state is we do have a methodology or a process for developing model permit conditions and language that we could begin to craft for these specific rules. So we had a group of people that put together some language for different engine types that could be crafted in and added into the permits that we did have. The permits that are easiest to change through a regulatory process are small and synthetic minor permits, and that's because we could send them this addendum and have them attach it to their existing permit and say this becomes effective 30 days after you receive it. Not so easy with a Title V permit. You can't just send them a set of permit modifications and say, here, just clip this to the back of your permit. There's a whole process in terms of opening a permit up and then placing the language in, having public comment, and what have you. So for permits that were coming through the process that were Title V, but we didn't have all the specifics, we put placeholder language in those Title V permits as they were open, and that's a process that's ongoing today. Our management did decide to keep the delegation. There's a couple of reasons for that. Probably the most straightforward answer is because we're the closest ones to the ground to them in terms of knowing or being able to deal with their specific permits, their specific facilities, and the sort of operation that they have on a day-to-day basis. So as time goes on, as we've developed these permit conditions, we started with a very broad and sort of generic permit language, and as we move further down and we get more refined, our permits are also refining the language to something much more specific. So there are fewer if-then statements around a broad, if your engine is above 500 horsepower compression ignition, there's a lot less of that. We now know what those engines are, and we're putting much more specific language into the permit. Now, what about the permit exempt facilities? Well, initially we identified approximately 100 or so non-emergency peak shaver facilities that were covered and required testing, had the record keeping and reporting. And the examples of those sort of facilities were things like grocery stores. We have a whole chain of grocery stores here in North Carolina that have these emergency engines sitting behind them, and they also operate as peak shavers. Some retail stores, a lot of local government operations for schools, police, fire stations, and also emergency operations centers. We found a lot of co-located engines in that there were like 4 or 5 engines located in the same place, but they all belong to a different person. Okay, so you have this site name, but then you had to figure out, well, does it belong? Who does it belong to? Does it belong to Lowe's? Does it belong to the city or the county or whatever? And the reason they're all co-located is that's the easiest place for them to access the grid. Another issue that we came up with is who's the actual owner and operator of these engines. So with some of these arrangements between like a grocery store and the people who then tie them into the grid, it gets a little iffy in terms of trying to figure out who's the actual owner and operator. And sometimes that's really important in deciding whether or not a source is a major source versus an area source. And we actually did have one of those situations where there was a lot of finger pointing about who actually owned the engine, and it really made the difference between whether they were a Title V major HAP source or it was an area source. So that's a challenge that I think we've pretty much worked through, but it was a problem right at the get-go. The other thing that was really interesting was we had this May 3rd, 2013 compliance date, and EPA had made some proposals to change the rule, and the timing of that particular promulgation caused a great deal, and I put it in quotes, uncertainty, both for us as a state regulatory agency and the regulated community, in that we didn't know exactly what those rules would look like, and they weren't promulgated until early January of 2013. We put forward the opportunity for these people who are under the 4Z rule changes for non-emergency engines to request an extension. We had approximately 100 of those requests for the existing engines for them to retrofit controls. And approximately a third of the facilities that came to us with these extension requests were permitted facilities that held an operating permit with DAQ. The rest of them were permit exempt. We granted all but one extension request. We had a uniform extension expiration date of May 3rd, 2014. Most of the issues were associated with getting the diesel oxidation control catalyst, getting it installed, and then later on just dealing with the testing that had to be done. But nonetheless, most everybody managed to get through this very successfully. There were a few people, when they looked at the cost at the end of the day, they went, you know, we're not going to be a peak shaver, and we're just going to stay as an emergency engine. But most of these people went forward with their projects. Melanie's already mentioned the Emergency Demand Response Program. We work with South Carolina DHEC and EPA on permit language and some other stuff, but that program has largely been eliminated by that Delaware versus EPA vacature. So a lot of engines that were under that program have gone back strictly as emergency engines from what we can tell. Some other issues that have come up that we've had to deal with as a state agency is we do get questions about, well, what load should be used for engine testing? We had a bunch of engines at the very beginning of the compliance cycle that went out and got load banks, which is the very next one item here. And they put load banks on so they could run the engine all the way up to its maximum load. But the real issue is, do they ever get there? And so there's some language within the rules that you have to read fairly carefully to decide what load is appropriate, what is representative. We have some engines that operate at different loads based on seasonal issues. Fall and spring tend to be lower operating loads compared to winter and summer. And so the big concern has been, well, I've got this pressure drop requirement as part of the 4Z rules to meet, and in those fall and spring seasons, I might not be operating at a high enough load to be able to check and confirm that my pressure drop's in the right range according to the rules. So we have people who are now testing at multiple loads so they can have full coverage and demonstrate that at various loads they have a pressure drop window and they can demonstrate compliance with the CO standards or the reduction standards. We have sites with multiple engines and requesting around identical engine testing and going through a sequence, and we've been working through that. We don't have a lot of sites here in North Carolina, but we do have some, and so we take an EPA's guidance and apply that. And the biggest issue that we've probably run into with the 4Z rules is people have had trouble with the pressure drop sensors and the alarms associated with them. We've had relatively few catalyst failures. We've had a couple where the turbocharger on the engine exploded and went right through the catalyst, and they had to replace the catalyst and had to go through the whole testing process. I'm going to do a little show and tell here as we get close to the end. So we've got another group of engines. We have a lot of compression ignition engines, but a lot of our testing focus and compliance work here deals with the non-certified engines that are basically spark-ignited engines. So here we have a hog farm. you can't see the rest of the hog farm. It's behind me here. But there towards the center of the picture, you see that building, and then there's a tarp, or it looks like a tarp. It's actually an impervious covering, and that's the digester, and it's creating methane and carbon dioxide as part of the digestion process. And that little building there holds the engine. And that's what this engine looks like here. This is nothing more than a marine engine. This is not in the hundreds of kilowatts. This is wow, thousands of kilowatts. This is actually a few hundred kilowatt engine. But this is an example of some of the digester gas engines that we do see on some of these farms. We have a fair number of them that are moving forward on this. This one's somewhat unique in that this engine here uses the waste heat from the engine itself to heat the digester, which puts the digester into a different operating range, so it produces more methane gas, and it's able to run more continuously and have the whole system run more efficiently. It's a bit of a bear to test, though. This is a more common sort of situation we see here. This is a landfill gas generator. This is about a 1 megawatt engine here, and you can see the testing group out there with their portable lift, and the guy sitting up there in the basket. We see an awful lot of this. We have a fair number of landfill projects here in the state, and we spend a lot of time going over the various issues. We have some state-only programs that a lot of these folks participate in. This particular unit right here sits 4 miles away from the landfill, so the gas is pipelined down to this particular location. Whereas some other ones here, this happens to be located next to the landfill. There's a couple of pretty good-sized engines. That previous engine, like I said, was about a 1 megawatt power output. These two engines here, they're about 1.6 megawatts apiece. And this, again, is on testing day. And if you look off there to the right, you can see the box sitting on top of the engine housing there, and the probe is in that particular stack the day that this testing was going on. So other issues that we have to deal with, we have a very small number of engines here that are classified as new under the Quad Z rules, but they don't have any NSPS requirements. And those are mostly spark-ignited engines burning digester gas, and they're in this little window that occurred between when they were new under the Quad Z rules and new under the 4J rules. So EPA acknowledges that that occurs. They've seen it in other locations, and we know it too. We do have a fair number of questions about non-emergency engines. Those are the peak shaver engines that are used strictly under emergency conditions where they have low load and demand. The classic is the engine that's sitting behind, that's a peak shaver behind a school. So it's a non-emergency engine used for peak shaving for the school. The school, though, ends up being the shelter during a hurricane, and it's otherwise completely disconnected from the grid. And the only lights that are being fed are those in the school, the HVAC in the school, and perhaps in the kitchen area. And they're running at extremely low demand compared to how much generating capacity they have. So there are issues in terms of whether or not they can actually get the catalyst temperature up to the minimum 450 degrees. We're working with different people who've come up with that sort of situation and having them go through on their next test cycle and actually run at low load and demonstrate that they can comply, and then we're writing it into their permit. We have a great misunderstanding by some users that those spark-ignited engines under the Quad J have a performance guarantee, but that is not a certified engine. As Melanie pointed out, it's a voluntary certification, and people think, oh, well, they say it'll meet 4J, but if it doesn't have the certificate of conformity, which we can look up online, it's not a certified engine. We've also had recently some engines tested at landfill sites, and although we have not required it as part of the testing protocol, they've gone through and used EPA Method 320 as the sampling and analysis methodology. And one of the things that's come out of that testing is because of the 4-stroke lean burn engine burning landfill gas, the engine has a tendency to produce a higher than expected level of formaldehyde. And we have an idea where the break point is in terms of what constitutes a Title III major source threshold, how big the engine has to be, and how many engines have to be on site. We've looked at data from other states, and we see that we're seeing the same sort of thing that other states are seeing. In very rough numbers, if there's more than about 2,500 horsepower of engine capacity on site and the burning landfill gas, then it can be an issue. And then the other issue that we've come up with in landfill gas engines is their rebuild cycles. These people have to rebuild these engines approximately every 8,000 hours, and so they get to be a bit of a challenge. We've done a bit of outreach. I know we're getting close to the end of time. We've done a bit of outreach with DAQ to various facilities that were possibly affected by the vacatur. We notified them of their switch of status by the change of the rule or by the vacatur that they could no longer be classified as an emergency engine. It ended up going into a non-emergency engine. And basically what we ended up doing was, for people who were in the program that had questions, we did a case-by-case determination. They sent us the information. We'd look at what they did. If they were an existing engine that was going to change status, they probably needed to retrofit a diesel oxidation catalyst. If they were a new certified engine, but they were certified originally for non-emergency use, then there was probably no issue. As long as they kept running the engine and meeting all the certification requirements, they were fine. We have a number of engines that are certified under the NSPS, but they're for emergency use only, and the vacatur would cause them to lose not only their emergency status, but their treatment by DAQ as a certified engine. Now, there's a tortuous pathway to deal with an engine that changes that classification. The end result is most of the people, they dropped out of the program, or they just have to buy a new engine. But non-certified, and then we end up with a whole class or a small class of non-certified spark-ignited engines potentially that could stay in the program because they would just be treated as non-emergency engines and have to meet the requirements. We do have, in each one of our regional offices, we have a regional resource contact, and I'm the central office contact and providing you the information today. So we're about to go into a quick question and answer session, and this is our contact information. Thank you.
Okay, thank you, Gary. We'll begin to answer your questions. So remember, if you have any questions, please type them into the question box and press the send button. We do have some questions queued up, and I'm not sure how many we'll be able to field here because of time, but we'll do our best. The first question is, this is regarding non-road engine definition purposes. If you have a, quote, portable, unquote, engine powering lights for night work that are garaged at a stationary source and used intermittently when needed, do they meet the definition of non-road engines?
So this is Melanie. I mean, I think, again, it's going to come down to whether these engines are remaining in the same location for more than 12 months. So if, every night you're taking them to, a garage, and then every day you're taking them out and driving them, 10 miles down the road, and using them at a job, and then you're taking them back and garaging them at night, and then the next day you're driving them, to another location. I mean, I don't think that's the kind of thing that we would typically consider to be stationary. But again, it really comes down to what's remaining in the same location. If you have a site-specific type of question, about the applicability, then I would encourage you to talk to either your state or your EPA regional office.
Okay. Next question. Regarding emergency engines, what is the difference in the RICE MACT / NSPS provisions for emergency demand response that were vacated and the provisions for which EPA sought received voluntary remand 50 hours for non-emergency situations as part of the financial arrangement? Fairly long. Did you understand the question?
Yeah. So the sort of the criteria in which that applies are different. For the emergency demand response, that was when there's the reliability coordinator, which is generally like your regional transmission organization or your independent system operator. So kind of the entity that is responsible for the reliability of the bulk power system has declared that there's an energy emergency alert level 2. So that's the criteria for the emergency demand response. And then for the 50 hours, the criteria is a little bit different. It's there the engine is dispatched by your local balancing authority or local transmission and distribution system operator. And then the dispatch is intended to mitigate local transmission or distribution limitations that could lead to interruption of power supply in a local area. So it's supposed to be more, issues that are occurring on the local system level, kind of below the purview of the bulk power system.
Okay. Next question. This is for diesel engines subject to NSPS subpart 3, and specifically the requirement to use ultra-low sulfur diesel fuel. What specific documentation does EPA deem sufficient to show the fuel bought or used meets the specification?
So for EPA, I mean, the rule does not stipulate a certain type of documentation or a certain level of documentation. So, it's kind of up to the owner-operator to keep whatever is sufficient. If you want to make sure that what you have would pass muster with, I guess, whoever's delegated the authority to implement and enforce the rule for the facility, then I would suggest that you talk with your state or your regional office, if you want to ask them about specifically a type of documentation. And Gary, if you have anything you want to add about what North Carolina would look for example.
We would, if we were looking at it, we'd just look at their fuel purchase records.
All right, very good. Next question, are the Quad Z area source non-emergency 4 SRB engines less than or equal to 500 horsepower not allowed to use the oil analysis program since item number 10 is excluded in 63.6625 subpart J? If you own or operate a stationary spark ignition engine that is subject to the work, operation or management of practices in items 6, 7, or 8 of Table 2C to this subpart, or in items 5, 6, 7, 9, or 11 of Table 2D of this subpart, you have the option of utilizing an oil analysis program. Again, that's a complicated question, but
I'm familiar with it, yeah. So what happened is when we were updating, the last time we were revising the rule and we were updating the tables and adding items to the tables, we just inadvertently neglected to go back and revise 63.6625J to update the item numbers in J. But the intent is that any engine that is subject to the oil change requirement to change the oil, on a specified frequency, be able to use the oil analysis program. And I think the table itself actually says that in a footnote. And so just next time we are amending the rule, we would fix that inadvertent error. But the intent is that yes, they would be able to use the oil analysis program.
Okay. And this question is directed at Melanie. Can you confirm the existence of a, quote, loophole, unquote, such that, quote, new, unquote, engines under the NESHAP rule aren't subject to the NSPS rule because of their manufacture date? And if so, can you briefly discuss what the loophole means?
Yeah, so that's the thing that Gary touched on a little bit, where you have an engine that is classified as new under the NESHAP, which means constructed after June 12th of 2006. And the engine, then all the NESHAP says that engine has to do for purposes of the NESHAP is to meet the NSPS, but it doesn't actually meet the applicability of the criteria of the NSPS because it was built before, like for example, that 2008 date in the spark ignition engine NSPS. So what happens in that situation is that the engine is technically subject to the NESHAP rule, but it doesn't have any requirements that it has to meet. And if you look at our Q&A document, which is on our website that I had the link for earlier, this is one of the Q's and A's in that document. So if you want to see, kind of a written discussion of that, I would go to that Q&A document.
Okay. One question we've had from multiple participants in the webinar, will we be able to get a copy of the presentations? You will be able to get a copy of the presentations, not the PowerPoint as such, but you will be able to get a PDF copy of it. It will also be available on the NASFA.net website under the, well, I'm drawing a blank on what area it's under. We've got a continuing presentations type of area there that you don't have to be a member to get into it to look at it. It will be a few days before that gets put up there, but we will make it available. So let's see if we can, learning series. Thank you, Marcia. It's the NASFA learning series. I should know that as the president, but at a senior moment. Next question, can the ISO/RTO emergency demand response programs be used under the 50-hour rule, parentheses, which imposes certain conditions that seem to be somewhat incompatible with some ISO/RTO programs, such as being used to solve local voltage or local congestion issues, close parentheses. Anybody want to take a shot at that?
Yeah, so, it's hard to give you a definitive answer without knowing kind of the conditions under which the ISO and RTO programs are called. That being said, the 50 hours was, if you go back and look at kind of the regulatory history and the supporting materials for the rule, the 50-hour provision was not really intended for the ISO RTO type of programs. In fact, it was based on comments that we got, particularly from rural cooperatives, said that they had situations that kind of fell outside of the purview of these ISO and RTO programs that they needed allowances for in the rule. So that's how the 50-hour provision came into being. So, I don't think they're generally intended to be overlapping, but again, without knowing the specifics of the ISO and RTO program, I can't say that definitively.
Okay. Another question. If you have a non-remote engine and move that engine to a remote area, is that engine still considered non-remote?
So if you look in the regulatory language, it specifies in the rule that the engine had to meet the definition of a remote engine on the initial compliance date for the engine, which was in October of 2013, in order to be considered a remote engine. So my understanding is that it had to be remote, on that date, October 2013, in order to be considered remote.
Okay. This is a question for North Carolina. What language in the Title V permits has North Carolina used to address the vacatur of the demand response provisions?
We haven't yet. If we have any open permits at the current moment that have the language in them, we are in the process of removing them. I'm not aware of too many facilities that actually have that language in the Title V permit itself, but it's not something that you could just easily rip out And unless the permit is open currently or is being open for another reason, we wouldn't necessarily open it up just to take that out. Obviously, it's a non-enforceable provision because it now refers to a regulation that doesn't exist any longer.
Okay. Is the definition of a location a property boundary? If engines are moved within a property boundary, example given to the other side of an on-site lot, but stay on-site for longer than 12 months, is this stationary? And it's subject to the stationary provisions.
So, I mean, the way the regulations define location is it just says a location is any single site at a building, structure, facility, or installation. So it's not necessarily tied to the property boundary. In terms of the specifics of, if it stays within the property, but moves around, is that, considered stationary? Not necessarily. I mean, we've done applicability determinations, which, you can find on our website, for engines that were moving all around the facility, regularly, even though they were remaining within that facility boundary, we determined that they were not stationary engines. So again, I think it just depends on, how often it's moved, how far it's moved, for what purpose is it being moved. Okay. And unfortunately, it often comes down to kind of a site-specific judgment.
Okay, I think we're running over on time. We'll try to get in one more question here. At oil and gas facilities where load is dependent on market demand, how do you think the performance test load requirement should be handled or interpreted?
So I guess for me, I mean, in some cases, we kind of recognize that engines may not always be operating at full load, so the regulation will say, test at full load, 90%, at least 90% load or 90% of the highest achievable load. If you have, kind of a situation where you think it's not, you may have trouble with the testing requirement and the load that's specified for the testing, then I would say, that's the kind of thing where you be wanting to be working with, folks like Gary at your state, air pollution control agency or your EPA regional office, and I'll ask Gary if he wants to add anything, since I know that's an issue he cited.
Yes. So generally speaking, if it's testing under the NSPS, which would really be kind of be the spark ignited engine, what we would say is what's representative, and so that's covered under 60.8 in the 40 CFR 60.8 in terms of the performance testing, as well as, I'm trying to remember if there's anything else that's really specific about that under Quad J. For the NESHAPs, for the Quad Z rules, again, we refer back to 63.7 unless there's something that's absolutely specific within the in the Quad Z rules. There are some specific load requirements for major sources of HAPs, and that gets to be a bit of an issue. But again, we look at that in the context of, yes, for what is actually achievable in terms of full load. I'll give you a great example of a situation we've run into a couple of times, where we have these really large engines, and I'm talking about like 5,000 horsepower engines. They will never, ever, 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 ever run at that sort of load. But when they bought them, they must have gotten a deal from the manufacturer, and they wanted to make sure they had enough capacity in case every engine except one failed, and they did have to run on a single 5,000 horsepower engine with its generator. Where we've required testing under those sort of circumstances, we've said to them, okay, you're not going to ever get up there under any sort of reasonable scenario So what's the most probable scenario, and run it at that particular load. And again, that's really driven by the by either the NESHAPs or by the NSPS. So we try to work with a certain degree of flexibility. Every once in a while, we get jammed a little bit by the regulations, but in most cases, I think we are able to accommodate those variations in load.
Okay, well, I think that's about all the time we have for questions. We do have some questions we didn't get to, and we will try to make arrangements to get answers directly to the questioners through email or other means. And so I thank everybody for participating on that. A special thank you to AAPCA and their representatives, Melanie and Gary, for sharing their expertise with both associations. The slides and recording of today's presentation will be made available by both associations in the next few days. If you like today's session and would like to see future presentations on specific topics, please share your suggestions with us. Feel free to send an email to NASFA@csg.org, NASFA@csg.org. Thank you again, and this concludes our program.